My name is Arman Singh and today I'll be presenting on the topic of nuclear waste and the Fukushima Daiichi nuclear disaster. We will explore how nuclear energy works, its benefits and challenges, particularly with nuclear waste, and touch upon the Fukushima Daiichi nuclear disaster. Let's get started. What is nuclear energy? Nuclear energy harnesses the power of atomic reaction primarily through a process called fission. It became mainstream in 1950 with a visionary leader like Louis L. Strauss predicting energy too cheap to meter. However, despite its immense potential, nuclear energy development has slowed down due to accident, safety concern, and political opposition. Now, I will be discussing how nuclear energy works. Nuclear fission process is the splitting of uranium-235 atoms releases energy. Key components of the reactors are fuel rods, control rods, moderators, and the cooling system regulate reaction and prevent meltdown. Nuclear reaction, control chain reaction, which is generated heat which is used to produce the electricity. Now I'll be discussing about the nuclear waste. One of the most critical issues with nuclear energy is the radioactive waste it generates. This waste may remain hazardous for the thousands of years, posing a long-term challenge. There are two primary types of nuclear waste. First one is high-level waste, which is primarily consists of spent nuclear reactor fuel, which is intensively radioactive and generates significant heat. It requires cooling and secure contaminant for thousands of years. Second one is low-level waste, which include items like contaminated clothing, tools, and filters. Although it's less radioactive than the high-level waste, but still it needs controlled disposal to prevent contamination. The main challenge with the nuclear waste is its safe disposal and storage, which is complex and very costly. Treating, transporting, and storing radioactive waste is an expense process. Constant monitoring is required to ensure the safety of the environment and nearby communities. This is not only poses a financial burden, but also require a logistical support from both government and the industries. These solutions often involve substantial investment and the long-term commitment. Next, I'll be discussing the nuclear waste disposal solution. First one is deep geological repositories. Store waste deep underground, isolated from ecosystem. Second one is reprocessing and recycling. Some waste can be repurposed through expensive and limited. So current example which I mentioned here is the Finland Onkalo respiratory is a leading model in the waste disposal. Now I'm going to discuss about the Fukushima Daiichi disaster. So the date of the accident is March 11, 2011 and the location was Fukushima Daiichi nuclear power plant, Okuma, Fukushima Prefecture, Japan. The main cause of the disaster was like 9.0 magnitude earthquake and the resulting tsunami that overwhelmed the plant defenses. There was impact level that classified as a level 7 nuclear event by the International Atomic Energy Agency, same as the Chernobyl disaster. Now I'll be discussing the sequence of events. Earthquake trigger shutdown. Reactor shut down automatically when the earthquake starts. Second one is tsunami flood plants. A 14-meter tsunami wave overwhelmed the seawall, flooding the plant and disabling the emergency generator. Third one is core meltdown. Without cooling system, the fuel in the reactor 1 to 3 overheated, leading to the partial meltdown and hydrogen explosion. Radiation releases. Radioactive material leak into the atmosphere and the Pacific Ocean, prompting mass evacuation. Next, I'll be discussing the impact of Fukushima disaster. First one is evacuation. Over 150,000 people were displaced and an incursion zone still remain around the plant. Environmental impact. The release of radioactive material contaminated in the air, soil, and ocean affecting agriculture, fisheries, and marine life. Ongoing cleanup expected to take 30 to 40 years, involving removal of nuclear waste and management of the radioactive water. Last one is wastewater releases. Recently, Japan began the releasing treated wastewater into the Pacific, which has raised environmental concern and stirred debates. Now, it's the future of the nuclear energy. Technological innovation. New developments like small modular reactors and fusion energy promise safer, more efficient nuclear energy. Fusion energy, a cleaner and virtually limitless energy source, though still in experimental stage. And its sustainability, nuclear energy could be a viable solution to help mitigate climate change, but it requires careful management of risk and waste. Policy and public support. Future growth depend upon addressing safety, waste, and gaining public trust. At last, I would like to conclude like nuclear energy holds significant promise to its efficiency and low emission, but it faces challenge with the safety, cost, and waste management. The future of nuclear energy depends upon its benefit with their risks, driving technological innovation and overcoming political hurdles. As we work toward as a carbon neutral future, nuclear energy can be an important part of the solution, but it requires a careful management and the innovation to commitment to the safety. Thanks for the listening. I hope this presentation has provided you with a comprehensive overview of the nuclear energy and complex issues surrounding it. If you have any questions, just let me know. Thank you.